A tornado is the most violent storm on Earth. Winds can top 300 miles per hour. Pressure inside the funnel drops so fast, it makes your ears pop. But how does a column of air on the ground actually get there? Let's break it down. It all starts with a specific kind of thunderstorm called a supercell. Most thunderstorms are messy and short-lived, but a supercell is organized. It has a rotating updraft at its core, a spinning column of rising air, sometimes 10 miles wide. That rotation is the seed. Without it, you don't get a tornado. The rotation comes from something called wind shear. Near the ground, winds might blow from the south at 20 miles per hour. A mile up, they blow from the west at 60. That difference creates an invisible horizontal tube of spinning air, rolling sideways across the landscape like a log. When a strong updraft punches into that tube, it tilts the spin vertical, and the whole storm begins to rotate. That rotating core is called a mesocyclone. Inside it, warm, moist air spirals upward, cools, and condenses. Radar can see it clearly, a tight hook of rain wrapping around a low pressure center. This is where tornado watches turn into warnings. For a tornado to actually touch the ground, the storm needs one more ingredient: a downdraft, specifically a rear flank downdraft. Cool, dry air rushes down the backside of the storm and wraps around the bottom of the mesocyclone. Scientists think this descending air helps stretch the rotation downward, pulling it toward the surface like taffy. As the column narrows, it spins faster. Conservation of angular momentum. The same reason a figure skater speeds up when she pulls her arms in. First, you see a funnel cloud, a visible taper reaching down from the base. It's made of water droplets condensing in the low-pressure core. The moment it makes contact with the ground or kicks up debris, it is officially a tornado. Inside the funnel, the pressure can be 10% lower than the air around it. That pressure drop, combined with horizontal winds, is what tears roofs off houses and flings cars through the air. The damage is how we measure strength. The enhanced Fujita scale from EF0 to EF5 rates a tornado based on the destruction it leaves behind. An EF5 can sweep a well-built home clean off its foundation. Most tornadoes live only a few minutes. They die when the cool downdraft wraps all the way around the funnel and chokes off the warm air feeding the updraft. The engine loses its fuel, the funnel ropes out, thins, and dissipates. The United States gets more tornadoes than any other country, roughly 1,200 a year, most of them in the Central Plains, where warm Gulf air collides with cold Canadian air. That collision zone is called Tornado Alley, and it's why storm chasers exist. Scientists still can't predict exactly which supercell will spawn a tornado, but radar, drones, and mobile Doppler trucks are getting closer every year. The more we understand these storms, the better warning times get, and the more lives we save. That's today's Science Simplified. Follow for tomorrow's study.